All right, so someone is asking me how to find the partial of z in respect to x of this function here. Let's say where z is given implicitly as a function of x and y. So we have here sine of x, y plus x squared, y squared equals to z cubed. And now if you notice here, z is given implicit as a function of x and y. And to find the partial of z in respect to x, what I'm going to use is the formula that we derived in class. But first what we're going to do is introduce a big function. Actually, I forgot there's a z here. So I'm going to put it over here. Right? So there's a z square there. So z is given implicitly as a function of x and y. So what I need to do is I want to find the partials in respect to x. Now using the multivariate chain rule, we actually showed that the partial of z in respect to x, right? The partial of z in respect to x is equal to negative the partial of some big function f that I'm going to introduce at this moment in respect to x of x, y, z. I'm going to introduce this function in a second, divided by the partial of this same big function f in respect to z. And we actually need to find this big function f. Okay, so let me actually do that. So what I do is I make a 0 on the right by subtracting z cubed from both sides. Okay, so let me make a 0 on the right. So this then implies this expression here, or equation implies that sine xy, okay, plus z squared x squared y squared minus z cubed is equal to 0. And now what I'm going to do is I am going to call this thing here big F of xy. Big F of xyz. So big F of xyz is going to be this expression right here. Sine of xy plus z square x square y square minus z cubed. So there it is. And in order for me to find the partial of z in respect to x, all I have to do is compute the partial of big F in respect to x and divide by the partial of big F in respect to z. And I am going to do that precisely now. So let me begin. The partial of big F in respect to x, so that's going to be this, is going to be, I have to differentiate this in respect to x. Okay, so the derivative of sine is cosine, perfect. Now I take cosine of xy, and I have to find the derivative of the inside with respect to x. Well, that's just going to become y plus the derivative of this term here with respect to x. Well, obviously, that's just going to become 2 z squared. Let's see, 2z squared. Okay, so 2z squared x y squared, and then the derivative of this in respect to x is just, of course, going to be 0 because there's no x term, no x factor there. So it's just going to be 0. And then I have to find the derivative of this in respect, okay, of this function f in respect to z. And I will do precisely that. Okay, so this is just going to be, okay, well, this does not involve the z variable, so this is just going to become 0. Here we're going to have then 2z x squared y squared, and then we're going to have here minus 3z squared, minus 3z squared. So there I have it. So now, in order to find the partial of z in respect to x, what I end up with, the partial of z in respect to x is just going to be negative, using this thing that we derived in class, is going to be equal to negative the partial of f in respect to x. Well, it's right here. Please check it. Okay, let's see. It's going to be right here. Okay, so negative. So it's going to be cosine xy y plus 2z squared xy squared to 2z squared xy squared. And then we have 2zx squared. Now the partial of f in respect to z is right here. It is actually 2zx squared y squared. 2z, okay, x squared y squared. And then minus 3z squared. And that's it. And of course, we also not only did this one, the partial of z in respect to x, we also derived the formula for the partial of z in respect to y, and all that you change is that instead of having the partial of f in respect to x, here, for the partial of z in respect to y, what you would do is you would put the partial, this would be the negative of the partial of, okay, of f in respect to y, big F, divided by the partial of f, big F, in respect to z. So the trick of the story, or the moral of the story, is basically, when you're given this expression here, you have to put a 0, okay, on the right. And then once you put a 0 on the right, you actually introduce the big function, big F of x, y, z. Okay? And then you compute the partial of the function z given implicitly as a function of x and y by this expression. You compute the partial using this formula or this formula. Okay? And of course, you have to assume that at the point x, y, z on the graph, okay, of this function here, of this expression here, right, at the point x, y, z on the graph of this expression here, that this denominator is non-zero, because if it is 0, you're going to have trouble. Okay, so you want to make sure that denominator is non-zero. Okay, and that is the story, and thanks for listening.